We're going to start this problem by rewriting it. And we're going to rewrite it like this. F of x is equal to x minus 1 over the absolute value of x minus 1 times x plus 2. We can put it over 1 if you want, just to make it symmetrical. And the reason we're doing that is because this expression right here is going to have a particular influence on the way that the graph of this function looks and on what the area is going to be. So let's start out, though, before doing this, let's just look at the function x divided by the absolute value of x. And in this Desmos graph, you can see exactly what happens, and it makes total sense. Because, say, for example, when x is 1, that's positive 1, and the absolute value of x is going to be positive 1. When x is 4, then that's positive 4, and the absolute value of positive 4 is 4. That's also going to be 1. But when x starts going negative over here, so for example, when x is negative 2, my negative 2 is going to be in the numerator, but my denominator is going to be positive 2. So that's why it had this jump discontinuity, and it turns into negative 1. So let's just kind of expand that a little bit. If I go x minus 1 divided by the absolute value of x minus 1, well, I have the same kind of a situation, but not surprisingly, I have shifted it to the right by 1 unit. Similarly, if I did, let's say, plus 2, or let's go plus 2, and plus 2 on the bottom, it would shift it to the left by 2. So if I have the same expression on the top and the bottom of a fraction, except that one of them is in absolute value, that is going to always create this jump discontinuity at 1 and negative 1, y equals 1 and y equals negative 1, and it's going to shift it to the left or the right. So taking that and applying it to the problem at hand, I can see that I'm going to have a shift from like positive to negative at x equals 1, equals positive 1. So my graph is going to look like this. As long as x is greater than 1, when x is greater than 1, I'm going to have the graph of x plus 2. But when x gets to be less than 1, then that's caused by this absolute value thing going on right here, I'm going to have the graph of negative x minus 2. So we're going to just pause there and let you think about that for a minute. You know, I'm not going to pause long. You can pause and make sure you understand what's going on there. And in fact, let's just look at it in Desmos. So I know this is a non-calculator problem, and you really couldn't, graph it to see. But once you understand this, how that absolute value of one expression over another that are the same expression, but one is absolute value, causes basically just a positive or a negative times whatever remains of the function at that cutoff point that's inside that expression. I hope that wasn't too long of a sentence and that it makes sense. So with this understanding, you should be able to graph this, make a little tiny sketch. So if I want to graph x plus 2, I know it starts here at 2, and my slope is 1, so it should kind of look like this. And if I want to graph negative x minus 2, Well, my y-intercept here is -2, and it's going to look kind of like that. This would continue on this way here. This would continue on this way here. But I am looking for the integral from, well, first of all, let's fix up the graph, because this is for when it's x plus 2 when x is greater than 1. So that means I need to do a little bit of erasing. All of this section right here is not part of the top part of the graph. And this is -x minus 2 for this part here. So this is going to be erased right there. And so, so this is what the graph should look like. And if we kind of look at it on Desmos, and you can see very clearly that I'm right. So since I'm always encouraging you guys to use graph paper, I'm going to use the Desmos graph because it has these nice graphs on it. And we're going to figure out the area this way. Because what I'm looking for is the integral from -1 to 3 of this function. So from -1 would be right here. And 3 is right here. So what I have is this integral right here, and then this integral right here. And I'm going to use area to calculate it. So I can see very clearly that now my bottom triangle here, I have -2 and another -2. So the area of this is -4. This was a -2 rectangle, and this was a -4 triangle. And here I have +2 area, and I have +6 area. So this positive area is 8. This area of this piece here is -4. 8 minus 4 is equal to 4. And as you can see, that is the correct answer.